Hello everyone, I am Ishita Singh and I'll be presenting my topic detection and mapping of flood inundated area using SAR, a key to resilient cities. This is a time series study in Mahi River Basin, India, which is done using ArcGIS Story Maps, ArcGIS Enterprise and ArcGIS Pro with Google Earth Engine, that is cloud computation technique. So, starting with floods are the most common naturally occurring catastrophic events that are severely impacted by human habitat and the city's construction, which changes the hydrological pattern of the river basin. This change in hydrological pattern induces heavy rainfall, which can act as flood and impact the human habitat and even the agricultural resources. So this is a greater need for the cities to adapt this computational technique to check out the water extent mapping and take informed decisions at right time. So the motive is monitoring and mapping of the flood, which is done using space-based sensors. So the techniques used are firstly the precipitation trend analysis, which is the major factor, and then the SAR Sentinel-1 multi-temporal images has been used for classifying using ortho thresholding, that is identification of water and non-water pixels will be our outcome. This will be done using time series Google Earth Engine technique. So urban areas and reservoirs are the two major factors that need to be monitored as they affect the hydrological cycle of the basin. This establishes the need for analyzing the rainfall trend and quantifying the temporal change in inundation area for flood resilient management. The dual polarization characteristic of Sentinel-1, that is the VV polarization, is of high spatial and temporal resolution that can even penetrate the cloud cover, which is at the bad weathers and at the night time also, which is a greater advantage so that we can monitor the real time flood events and the water and non-water pixels and how they are changing with time. This makes are the best approach for the time series water pixel detection technique. So in this Google Earth engine and the ArcGIS story map has been beneficial for the study because it does a rapid flood assessment, which is lagging in most of the cities and the government bodies in today's scenario. So the study is Mahi River Basin, and this is a semi-automated pipeline made up in Google Earth Engine for analyzing the precipitation trend and mapping of the flooded regions. So starting with the morphology and past flood study. So this is a stream order of the Mahi River Basin showing the base map of the elevation, the locations of the case study area, that is the Vadodara city, the two reservoirs, that is Kadana and the Panam reservoir. So one of the India's main west flowing river, the Mahi River, empties into the Gulf of Khambhat. The elevation 500 meter above the mean sea level it has, and it starts from the northern side of the Vindhyas. The Mahi Basin receives around 900 millimeter of rainfall and an average from 1971 to 2004. The water resource infrastructure faces surface expansion in reservoirs, which is induced through the stream flow. That's why it's very necessary to observe the reservoirs, the time series water extent of reservoirs, to take informed decision by government bodies for the urban areas in the vicinity of the river basins or the reservoirs. The Kadana and the Panam reservoir crosses the water level which needs to be tracked for the informed decisions, and the Vadodara city has experienced water logging and the flood issues due to swelling of the Vishwamitra river as shown previously in the map. So firstly, the precipitation trend analysis has been done and the story map has been of great use to see the change in the and a variation in the average and the total precipitation through the CHOPS Penta dataset has been used for this, which is of resolution of 0.05 degree. So we can observe the central and the southern part of the basin has the highest rainfall. The monthly average rainfall trend from 2014 to 2020 is done using the dataset of global satellite mapping precipitation, which is the hourly dataset. So we can observe that in the Mahi Basin, the trend is increasing and the peak ranges during the monsoon periods mostly. And for the Vadodara city, it can be seen 2019 it faced a flooded issue. So it has the highest during the July and August. So this is the month-wise precipitation data from the IMD, and it can be noted that July to September the rainfall is peak, and in August rainfall is increased from 93.1 millimeter in 2015 to 540 millimeter in 2020, which is a very big range. Comparing the trend for both the datasets, the CHOPS and Penta dataset and the GSMAP RD dataset, it is well versed with the IMD dataset. Therefore, this is a great backbone for the flood inundation mapping. We have the trend time series trend of the precipitation dataset also. Then SAR Sentinel-1 preprocessing has been done. So this map shows the visualization of the RGB composite of the Sentinel-1 data in which the VV backscatter, VH backscatter and VV by VH ratio has been seen. So it can be noted for the pre-flood and post-flood scenario, the VV polarized layer has been taken and it ranges from -25 dB to 0 dB. So the darker area shows the water which is a smoother surfaces, has low backscatter of -25 dB, have darker shades, and the lighter shades are the urban areas or the rough surfaces. So many filtering techniques has been used, which is speckle filtering, so that we have the refined version of the very polarized layer. Leaf filter technique has been used, which uses the weighted average of each pixel surrounding the pixel. The more filtering techniques has been used to refine the results. Water pixel thresholding, ortho-thresholding has been used, which is done through the backscatter value. So the DN number is converted into log scale for a better contrast view, and the water pixels has been classified from the non-water pixels. So then refining of the results has been done through semi-permanent removal water pixels and steep slope pixels removal. For that, global surface water mapping layer has been used in that seasonality, where the pixels where water is there for all 12 months has been removed, and the highest steep slope pixels where water can't accumulate has been removed. So this is the visual view for the Kadana reservoir, the first study, the initial and the refined pixels. We can clearly see through the story map technology, like the steep slope pixels and the all-time seasonality has been removed. So red ones are the water inundated areas, the final inundated areas, and similarly for Vadodara city has been done. Then this is the time series water extent mapping. This link goes to the code editor file of this Google Earth engine. This is rapid, like you can click and you can get the current water extent for the reservoir for every month. This is the area and the number of inundated pixels date wise for the Kadana reservoir, and similarly for the Panam reservoir. So what is the conclusion of the study? The study presents a methodology to map the surface water extent, that is using the freely available global resources data, which is very important. And the methodology is developed entirely on Google Earth Engine cloud computation and has been visualized on ArcGIS story map, which is more beneficial for the user. The method allows the detection of inundated pixels with more and good accuracy at day and night time, and the adverse weather conditions also, which is very important for the governance and the disaster risk management of any city. This will also help in sustainable development of cities and the basins, and good informed agricultural practices also, so that we can keep track of the reservoirs conditions also. Thank you so much.